Good afternoon, everyone. In this talk, I'll try to give you an overview regarding artificial intelligence in sepsis. The past decade has seen an enormous enthusiasm and it has shown exponential growth in the use of artificial intelligence in the healthcare industry. The concept of artificial intelligence. When we look at the literature regarding artificial intelligence, we may come across a lot of jargons like artificial neural network, deep learning, dimensionality reduction, machine learning, data science, unsupervised learning, which may perplex a non-information technology personnel. But what lies at the heart of all these terms is these are a set of tools or algorithms to get meaningful information from a huge amount of data. The problem of sepsis. Sepsis still remains one of the biggest challenges in the healthcare industry because of its burden and complexity. A study in 2017 published in Lancet has revealed that the incidence of sepsis is around 48 million per year worldwide, out of which 11 million die, and even in the survivors, there may be lifelong consequences. A host response to an infective agent is determined by a lot of factors including genetics, host comorbid status, and the virulence of the infective pathogen. What is basically a contained inflammatory state, which is shared by a lot of non-infective conditions like pancreatitis, burns, trauma, quickly turns into a life-threatening organ dysfunction because of the dysregulated host response. Is AI the pathway? Because of its ability to analyze a large amount of data, AI can be used to predict, prognosticate, and decide treatment in sepsis. Machine learning falls into three basic patterns. One is supervised learning, where the variables and the outcomes are known, and the role of AI is to find a relation between the two. That is, what function of X leads to Y. When the outcome is continuous, it is called regression, and when the outcome is discrete or binary, it is called classification. In unsupervised learning, the AI analyzes the data, lots of data, tons of data, to find any clusters. And the terms involved are clustering and dimensionality reduction. In reinforcement learning, a model for optimal decision making is done by using punishment and reward reinforcements. In supervised learning for sepsis prediction, a part of a large amount of data with well-defined variables and the outcome is analyzed by artificial intelligence to find a predictive model. And the rest of the data is used to test whether the model predicts the outcome of interest with the highest accuracy. In the study, a large amount of data of the sepsis patient is analyzed by the artificial intelligence to model onset of sepsis, onset of severe sepsis, and to predict septic shock 4 hours before its onset. These figures shows the area under the curve for the models predicted by machine learning and by the models predicted by the traditional scores which we use like SIRS, Muse, and SOFA score. And it's very clear that the area under the curve for the model predicted by the machine learning is better. In unsupervised learning, tons and tons of data are analyzed by artificial intelligence to look for clusters or latent subgroups. In this study, a large amount of information of patients with sepsis is analyzed by the AI, and 4 different phenotypes of sepsis with mortality implications is identified. You can obviously see the alpha phenotype has higher 28-day mortality compared to the other phenotypes. In reinforcement learning, an agent acts on an environment which is at a particular state and observes for a favorable change in the environment, which when occurs is rewarded promptly. A model for optimal decision making is done in such a way that there is maximum rewards and minimum pathway in the decision making, minimum punishments in the decision making. This can be extrapolated like a physician administers antibiotics timely in a patient with sepsis to see him improve, and the reward is reduced mortality. In the study, the MIMIC 3 cohort, which is one of the largest online critical care cohorts based on 7 hospitals in US is used. 80% of the data is used to train the AI to decide the optimal treatment strategy based on alive and dead patients with sepsis using reinforcement learning. And the remaining 20% of the data, the AI is allowed to decide the optimal treatment. And what happened, what did the clinician do, is given in the figure B. It is obvious that AI has suggested less use of IV fluids and more an early use of vasopressors, signaling that there may be a subgroup of sepsis patients whose mortality improves with less use of IV fluids and early use of vasopressors. The literature regarding AI in healthcare seems to be in the last mile, meaning we have excellent methods for data capture, good understanding of the predicting models, but the real world implementation and the routine use are lagging, which might be because of the limitations, overfitting. It is nothing but an exaggerated association between a variable and the outcome because the AI is specifically trained on a particular population, less generalizability. In the data of 2 different homogeneous populations, when analyzed by AI for predictive models, the 2 models have only a few overlapping variables, suggesting that each hospital or group of institutions should have their own version of the predictive model, thereby decreasing the generalizability, less applicability. The number of variables involved in predicting a model may be too high, that the level at which, for example, a tertiary care level where this model is predicted may not be applied to the primary care level because we may not have all the information in the primary healthcare. So the external validation remains the biggest challenge, and RCTs should tell us the truth, whether AI-based algorithms definitely make a change to become the routine standard of care. Thanking you.